All right, here we are in 10.7 on elasticity of demand. Here we're going to look at relative rates of change and the elasticity of demand. Okay, so when will a price increase actually lead to an increase in revenue? To answer this question and then study the relationships among price, demand, and revenue, economists use the notion of elasticity of demand. So, by definition, the relative and percentage rate of change is as follows. So the relative rate of change of a function f of x is found by taking the derivative of x, so a derivative of f, so f prime of x divided by f of x, or basically equivalently, the derivative of with respect to x of ln of f of x. So that's what we're actually taking the derivative of, and when you do that, that's what you get here. Now, the percentage rate of change is basically just multiplying it by 100, so you still get 100 times f prime of x over f of x, or 100 times d dx of ln of f of x. So those are the two differences. Relative rate is just the f of prime over f, and the percentage one takes 100 times that. Okay. Now the alternative form for the relative rate of change, d dx of ln of f of x, is called the logarithmic derivative of f of x. Now recall d dx of ln of f of x is going to be f prime of x over f of x by the chain rule, because you're going to take the derivative of ln, so that's going to give us 1 over what's inside here, which is f of x, and then you take the derivative of the inside, which is f prime of x, and so that's why this is what you get by the chain rule. All right, so what we're going to do is we're going to model the population data is given here, and it's given as f of t equals 2.7 plus 282, where t is between the is years since 2000 up to the year 2012. And what we're supposed to do is find and graph pt, the percentage rate of change of f of t for 0 to 12 for t. All right, so what we need to do is to find the percent rate of change, we need to take 100 times that derivative of f of x divided by f of x. Okay, so remember the percent rate of change. So we'll say the percent. Okay, well, we'll go backwards here. The percent rate of change is equal to 100 times f prime of x over f of x. Now, if we just want the relative rate of change, then we just take the f prime of x over f of x. So instead of f of x, we're doing f of t, so nothing too different. So what we need to do is if we want to find p of t, which is our percent rate of change, then we're going to take 100 times, now we're going to take the derivative of this, which is going to be 2.7 divided by this, which is 2.7t plus 282. Now, if we take 100 times 2.7, there's 7 there. That's going to be what? Well, that's going to be 270 over, and then we have 2.7t plus 282. Okay. So now we can graph this, and so let's go to that right now. So all right, so going over to our graphing calculator, I have typed in our equation. So the 270 divided by the 2.7x plus 282. My window, I'm going to set that from 0 to 15 because we know it's 0 to 12. So I'll go a little bit further by 5. And then I'm just going to guess 0 to 2, and I'm just going to go by half. So if we do that, this is what our graph looks like. So this mark would be actually at the 1, so it's just below 1, and it slowly goes down from here. So it's, it's if we do a trace, we go all the way up to where it is 0, and we have 0.95, and if we go clear to the other end, we're going to be not too far down. So 12. A little bit far, but that's okay. We're about 8.86. So that's really what it looks like. So that's what our graph would look like if we were to do it by hand. And so again, if we do this by hand now, we know that it starts about 1 and it's going down, straightly out here until it hits about 12. So we know we're going from 0 to almost 1 and 0 to 12, and that's what it's going to look like. Again, better lines can be drawn, but that's the general idea of what we would do there. So again, what we had to know was the percent rate of change. We're going to take 100 times the derivative of f over f of x, and in this case it's f of t, but that's okay. And then we get our value, and then we can plug that in and find our graph that way. All right, so let's stop there and we'll come back for more.